Yes.
Okay, thank you. So do you have any doubt from the previous class?
No.
No. So basically in the last class, we had studied about the electronic configuration of this. Basically, we were studying about how do metals and non-metals react, in which I started a topic that is basically the electronic configuration of metals and non-metals. Now, this was the electronic configuration of non-metals. Are you aware of this? Did you write it in the previous class?
Yes.
Today we are going to start the electronic configuration of non-metals. Non-metals. So the non-metals may and then oxygen, fluorine, then I am taking phosphorus, sulfur, and then chlorine. Now I'm going to write the atomic number. Its atomic number is 7, then 8, then 9, then 15, 16, 17. Please do the electronic configuration, or I'm going to write number of electrons in shells. So basically this K shell, L shell, M shell, 4 shells are there. Are you done with this?
Yes.
So you can see basically first shell will have 2 electrons. The atomic number will be equal to number of electrons in neutral atom. Since you can see there is no charge on this atoms or elements, so it is neutral atom. So the basically atomic number will be equal to number of electrons. So in the first cell, 2 electrons will go. So now we will have 5 electrons left, and in second shell, third shell, and fourth shell. Second shell, third shell, and fourth shell, 8 electrons will go. Max 8 electrons, maximum 8 electrons. So we have only 5 electrons. So this is the valence electron. What is valence electron? In last class, I explained what is valence electron. Can you tell me what is valence electron?
Sir, valency of a non-metal or a non-metal.
No, valency is something else. That is combining capacity. Valence electron, the electrons present, you can see here, electrons present in the last shell is called valence electron. But the valency, you can see, if the valence electron is up to 4, like if the valence electron is 1, 2, 3, 4, the valency will be equal to valence electron. If valence electron is more than 4, then valency will be equal to 8 minus whatever is the valence electron. So if you are going to calculate the valency of this atom, this element, so this it will have a, you can see the
8
valence
minus 5,
electron is
3.
5, so the valency will be 8 minus 5. That will be very good. So if you are going to do the electronic configuration, it will be 2,6, here it will be 2,7, here it will be 2 and 8. In the first cell, 2 electrons will go, then 8, and then we will have 5. So in the third cell, 5 electrons. Now 2, 8, 6, and again 2, 8, 7. Because its atomic number is 17, that means the electron number of electron is 17. So in the first cell, 2 electron will go, and in second cell, it will be 8 electron, and we have only left with 7 electrons, which will go in the last cell, that is valence electron. Now tell me the valency of this. It will have a valency of 2. What is the valency of this? 1. And what is the valency
3,
of this? 3. Valency
2,
of this? 2.
1.
So basically, in the previous class, I have explained basically what is a stability. If one element which has electron completely filled in their shell, that is called that means basically that element is stable. You can see in noble gases, every elements get completely filled electrons in their shell. That's why they are called noble gases. They are stable, and if they are stable, they do not want to react. That means they are very, very less reactive, not reactive, you can say that. But in metals and non-metals, you can see the electrons present in the last shell is not completely filled. In order to get a stability of that element, either they will lose electron or gain electron, or either they can share electron. So this sharing of electron we will study in the 5th chapter of chemistry, that is carbon and its compound. But here we are going to study about ionic compound. What is ionic compound? Basically, when metals and non-metals react. As we know that metals had the property that is electropositive, or we can say metals are electropositive element. They lose electrons. The valency of metals are generally very less, like 1 to 1 2. So they can easily lose electron to get completely filled shell. Because if they wants to gain electron, if they wants to stable by gaining electrons, it is not possible. Because you can see, in order to gain a stability by gaining of sodium, it will require 7 electrons to add in this. But in order to gain a stability, if it will lose 1 electron, it will get a stable. It will be stable because after losing, it will achieve noble gas configuration, noble gas electronic configuration. So it is easy to lose one instead of gaining 7 electrons. Is that clear, Azaan?
Yes.
Azaan, I'm waiting for your reply. Oh, your internet connection. Azaan, did you hear that? What I was telling you is that
Yes, sir.
in order to achieve a stability of an element, so was this clear that sodium will lose one electron instead of gaining seven electrons? Okay. So in non-metals, you can see in order to get a stable, oxygen will get, what do you think? Oxygen will gain 2 electron or lose 6 electrons? What do you think? Azan, am I audible to you?
Yes, sir.
So can you tell me, in order to get, what is the stability for an element? Just answer me this. What is the stability for an element? If the electrons, if the electrons present in an element are completely filled in their shell, that means that element is stable. So in metals and non-metals, you can see this is non-metal which has only 6 electrons in the outermost shell. In order to gain a stability, either it can lose all the 6 electrons so that the first shell will be completely filled, and in order to gain a stability, it can gain 2 electrons to complete this uh, complete this shell with fulfilled completely filled electron. Are you getting my point? So can you tell me what will be easy for oxygen to gain 2 electrons or to lose 6 electrons?
Sir, to gain 2 electrons.
To go, gain 2 electrons. That's why generally not these are non-metals, and you can see it will gain 3 electrons instead of losing 5 electrons. It will gain 6 electrons. It will gain 2 electrons instead of losing 6 electrons. It will gain 1 electron instead of losing 7 electrons. It will gain 3 electrons instead of losing 5 electrons. It will gain 2 electrons instead of losing 6 electrons. It will gain 1 electron instead of losing 7 electrons, because that is easy for this element. Are you getting my point?
Yes.
So whenever a non-metal and a metal, whenever a metal and a non-metal react with each other, they form ionic compound. They form ionic compound. I can show you. There is a sodium and there is a chlorine. So first I'm going to talk about sodium has a symbol of Na, which has electronic configuration Na. Sorry, which has a atomic number 11, which has atomic number 11, and its configuration will be electron distribution will be 2a and 1. And you can see chlorine will have a symbol Cl, and it will have a configuration 2, 8, 7. So what will happen here? Sodium will Sodium has a configuration 2, 8, 1. What it will do? It will easily lose electron. And if an element will lose 1 electron, it will have one positive charge. If an element will lose 2 electrons, that means it will have +2 charge, and if and so on. Are you getting my point? And this
Yes, sir.
becomes sodium. This becomes sodium ion. Now come to chlorine. Chlorine has a configuration 2, 8, 7. And what will chlorine do in order to achieve noble gas configuration, or in order to get a stability? Whatever is there, you can see this electron will be gained by this chlorine, and now it will have a charge Cl minus. Chlorine has an electron, which means the electrons in neutral state of chlorine will be 70. But after gaining 1 electron, its electron will become 18. So electronic configuration or the distribution of electron will be 2, 8, 8, and you can see this is chlorine ion. So this will have positive charge, this will have negative charge. As you know that positive and negative charge attract each other, yes or no?
Yes, sir.
So this will be attracting each other, and there will be bond formation. That bond is called ionic bond, and the compound formed is called ionic compound. Please write it. Then I'll show you electron dot structure.
Okay.
Let me know when you are done with this. Are you done with this? Very good. Now see how we are going to show electronic, basically this electron dot structure of this. So sodium has an electron in its outermost shell, that I'm going to show it like this, and chlorine will have outermost shell. The valence electron are 3. So basically, wait a minute. I'm going to put this electron as cross mark and it will come here and join with this. Now again, what will happen? Na plus will be like this, and you can see two, four, six, seven will have a negative charge. This positive and negative charge will attract each other. That is basically that will be the formation of bond that is called ionic bond, and compound is called ionic compound. Please write it.
Are you done with this? I'm going to define now what is ionic compound.
Yes, sir.
Please write with me. An ionic compound is defined as the compound formed by the oppositely charged ions by the ions which attract each other to form a chemical bond. Chemical, you can take example as example, sodium chloride. Sodium chloride. I just took the example of this. Just let me know when you are done with this. Are you done with this, Azaan? Azaan,
Yes, sir.
electron dot structure of any element or any compound. Now see what you need to do. If there is aluminum, you just need to show the valence valence electron, or basically electrons in last shell, electrons in last shell. So if we are going to take example of aluminum, we know the configuration will be 2 comma 8 comma 3, and you can see this is first shell K and then L and then M. In the last shell we have 3 electrons. That means aluminum. I'm going to show the electron dot structure like this. If we are going to show the electron dot structure of sodium, we know valence electron of sodium is 1, so I'm going to show it like this. If we have fluorine, to write the electron dot structure of this, we just need to show either by dot or cross Can you see the screen, Azam?
Yes, sir.
Okay, please write it and let me know when you are done with this. Are you done with this, Azam?
Yes.
Okay. So I'm going to give you write electron dot structure of following. Here it is sulfur, and then chlorine, and then potassium. There is calcium. Also there is argon, and then also there is phosphorus. Please show write the electron dot structure of this, and you have, if you have any doubt, let me just ask me, please. Are you done with this?
No, sir. 1 minute.
Okay. See, I'm going to explain the first one. Can you tell me the atomic number of sulfur? You have to remember from 1 to 20. Okay, Azaan. So sulfur has the atomic number 16. So in the first shell, it will have 2 electrons. In the second cell, 8 and then 6. And this electron data structure is the representation of valence electron. So you can see in the valence electron or the valence electron of this sulfur is 6. So you are going to represent it like this. So this is the electron dot structure of sulfur. Is that clear?
Okay, sir.
So now can you do the rest one?
Okay, sir.
Okay, waiting for your answer. Hmm.
Done.
Done?
Yes.
Very good. So now I'm just match the answer. This is chlorine. Chlorine will have 2, 4, 6, and 7 because its valence electron is 7. Potassium only 1. Calcium will have 2. Argon will have 8. Phosphorus will have 5. Yes or no?
Yes, sir. Yes, sir.
Very good. Can we move to the next part?
Yes, sir.
Now answer me. I just did the formation of NaCl in this way. There will be question for 3 marks for you. Write the formation or of ionic compound of NaCl. So you have to follow all the steps. Na and then configuration, chlorine and then configuration, then sodium losing one electron, chlorine gaining one electron, and then the last step is this. So in the same way, you are going to write the formation of first KCl. KCl. That means the formula is KCl and the chemical name is potassium chloride. Can you do in the same way? This is very important. Please do it. We will do some questions, some compounds on this, and then we will move to the next topic, properties.
Sir, can you say the question again?
Wait a minute. The question is basically show the formation of KCl. Show the
Okay, sir.
formation of KCl. So how you are going to show? The way I made NaCl. Let me know when you are done with this. I'm waiting.
Sir, done.
Very good. So how did you do it? Potassium
Sir,
as a
potassium will
configuration.
lose one electron, sir.
Very good. Like this. And have you written it like this? Or no? You have to do it in the subjective way. Potassium ion. Then chlorine will gain one electron and form Cl minus. And then again, you can show like this. Did you do in the same way? Or you just did it in shortcut way? Tell me. Azaan, did you do in the same way or the shortcut way?
Sir, same way.
Very good. So this was the first question on this part. Now the second question, you need to show the formation of MgCl2, that is magnesium chloride. Can you do this?
Yes.
Okay.
Done, sir.
Are you done?
Yes, sir.
So how did you do it? Magnesium,
Sir, same.
same way, 2,8,2, and then it will be converted into Mg plus 2. That means it loses 2 electrons and it will have now noble gas configuration, and chlorine will come and gain 1 electron. So 2 chlorine will come in order to gain 2 electrons, and this will have a configuration 2,8,1. Now this will be 2Cl minus, which will have a configuration, sorry, 2,8,7, and it reflects. This is chlorine ion, and this is magnesium ion. And we can write it like this. Done. Are you done with this?
Yes, sir.
Very good. So now I'm going to write some properties of this compound. You need to write it too. So write characteristic of ionic compound. Characteristic of ionic compound. Ionic compound. Characteristics of ionic compound. Now see, the first characteristic we are going to talk about physical nature. Physical nature. Basically, the ionic compounds are very hard. Why? Because the electrostatic force of attraction, the positively charged attraction force is very high. That's why their physical nature is very high. That's why ionic compound exists in solid state. So I'm going to write a point about this, which is ionic compounds. Ionic compounds are solids. Ionic compounds are solids because solids and hard we can write hard because of the strong force of attraction, because of the strong force of attraction between positive and negative ions. So question can be asked like, why ionic compounds are solids or hard? Because of the strong force of attraction between positive and negative ions. Also, we can write a point which is very important. These compounds are brittle. These compounds are generally brittle and break into pieces when pressure is applied. So these points are very important, and the questions can be asked in long answer types question, 3 marks or 4 marks. Why ionic compounds are solid and hard, or why ionic compounds are brittle? Because they are hard and hard due to the strong force of attraction. When pressure is applied, they break into pieces. Please write it and let me know when you are done. Are you done with this? Azaan, are you done with this? You were not audible.
Yes, sir.
Okay. So this is it for today, Azan. I'll see you in the next class. And in the next class, probably we are going to end this chapter. And also, if there is
Okay.
any test or exams in your